Hello everyone, we are Group 5 of Section 19, presenting you with a computer-driven automobile safety system. Our aims are to track drowsiness of a driver while driving and provide an alert using computer vision algorithms. We also plan to include a mask detection system to detect absence of mask and therefore reminding the driver to wear a mask. Together, we aim to improve driver safety.
This is a brief demonstration of our project. We mostly wrote the code in Python. As you can see that on the left, .py files are there. They are written in Python. Whereas our profiling part, where the actual profiles of different people are trained, is done in MATLAB. There are other files too. These are called HAR cascades, which are actually open source from the internet. They are predefined to find out where eyes and face of a person are. So we will be using this data, which is taken from the internet, to find out where eyes and the face of the person is in our code. So first of all, we are supposed to train our model. It uses eyes closed and open. This train.py takes nearly 200 images of the user in which both eyes are open and closed, and throws out data into an Excel file. The data includes the ratio of width to length of eyes in closed and open state. Let me just show you. I'm running this file. I'm training it now. You can see there are two new files in the left side, which correspond to the data of my eyes in closed and open states. This is very raw data. We need to process this data in order to get a suitable function, which is precisely what this MATLAB function does. This is a machine learning algorithm. What it does is it takes in the data which is generated by the training module and it sends it to this optimization function. What this optimization function does is it creates a function which can best fit the data of my eyes. I'll just show you. This is the actual function generated by MATLAB training model. If you can see, the value corresponding to the ratio is mapped to a particular probability of my eyes being open. For example, if the ratio is 400, for my eyes, the model will be 90% sure that my eyes are open, something like that. Now we shall implement the code. For that, I will run this Python file. And as you can see, also in the left, we have a new Excel file which corresponds to two parameters which define the function which I just showed. Okay, let me just run this file. As you can see, there is a parameter corresponding to my eye state. The model is pretty sure that I open my eyes. The probability is nearly 95%. And if I try closing my eyes, it would be like the probability decreases to a very low value. That means my eyes are closed. If I try to close my eyes for a long time, then we should hear a beep sound. And the beep sound also came.
We will now go through the mask detection algorithm. As I previously mentioned, we take the help of HAR cascades to point out different parts of the face. Then we use the fact that wearing a mask will cover user's face but expose the eyes. Then we can conclude that the user is wearing a mask. We wrote an if-else conditional to decide the output. As you can see here, there are if-else conditionals. Clearly, when the mask is not there, the face and eye are visible, so the buzzer goes off and therefore alerts the driver. I'll just run the code now. Here you can clearly see that I'm not wearing a mask, and the code detected a face, but there is no mask. If I try wearing a mask, the beeping sound also goes off and the mask is changed to found here. That's the implementation of mask detection algorithm. Finally, I will now demonstrate the whole project with proper user interface. Let me just run this code. I'll just follow the on-screen instructions. Okay. Okay, the calibration is done. I shall just press to start the safety module. So as you can see, it also detected my mask and it is pretty sure that I am not asleep. If I try closing my eyes, it is making some sounds. It is detecting that I am asleep, and you can see that the sleep nature is gone to true. If I just open my eyes again, the sleep is now false.